What happens when you cross the edge of the universe? Strange things happen when you reach the edge of the universe. Can you see the Creator depicted in 19th century engravings? To find the answer, today we're sending you beyond the boundaries of the cosmos. Take a look. What's out there? Imagine you're aboard a spaceship, flooring the accelerator in one direction, speeding away from Earth. You travel close to the speed of light, and you have an infinite lifespan. What will you see when you cross the boundary of the universe? Will you crash into a wall, or pass right through it? If you do pass through, where will you end up? This question has puzzled humanity for thousands of years. A 19th century illustration shows how people in the Middle Ages imagined the edge of the universe. Beyond it lies the mechanism that controls the cosmos. But we still don't have a definitive answer. Today, we'll explore some of the most plausible theories to investigate what lies beyond the most obvious, yet most elusive boundary of the universe. First, let's clarify a few key points. When you look at someone, you're actually seeing them as they were 3 nanoseconds ago. When we look at Betelgeuse in the Orion constellation, we're seeing it as it was 500 years ago. It might have already exploded. The same applies to gravity. The sun we see is how it looked 8 minutes and 20 seconds ago. Likewise, the Earth is affected by the sun's gravity from that same point in time. If the sun were to suddenly vanish without a trace, the Earth and other planets would continue orbiting an empty point in space for a while, before eventually drifting away in different directions. There's more. The Andromeda Galaxy is racing toward us at about 400,000 kilometers per hour. But it's actually 900 light-years closer than it appears. In short, you can never see anything in real time. The farthest distance we can observe is the point where light has reached us since the Big Bang. The nearest such point is over 46 billion light-years away. That 46 billion light-years marks the boundary of the observable universe. Are there remnants beyond this distance from before the universe was born? But what we're truly looking for is the actual boundary of the universe, not just the edge of what we can observe. When it comes to the edge of the universe, astronomer David Kipping gave one of the most detailed explanations of the question. In this thought experiment, imagine your spaceship starts off as follows. In the first second, it travels at 10 meters per second. In the second second, 20 meters per second. In the third, 30 meters per second, and so on, accelerating continuously. After 35,283 hours, your spaceship would pass the moon. A week later, you'd fly past Saturn. 11 days in, you'd pass Neptune, the farthest planet in our solar system. For the sake of this thought experiment, let's ignore practical problems like fuel supply or catastrophic collisions with space dust. After about 15 months, you will have traveled your first light year. At this point, the effects of Einstein's theory of special relativity begin to appear. As you accelerate to a speed of 299,792,055 meters per second, the final 3 meters per second needed to reach the speed of light would require all the energy in the universe. And even then, you would only ever approach the speed of light, 299,458 meters per second, never actually reach it. Without this limitation, your spaceship would exceed light speed in just 45 days. But in reality, things play out differently. Special relativity tells us the faster we move through space, the slower we move through time. As a result, some truly counterintuitive effects occur. From an external observer's perspective, your spaceship seems to slow down as it nears light speed. You appear to move in slow motion. However, from your own perspective inside the ship, time flows normally. You continue accelerating at 10 meters per second squared. Even more bizarre, to an external observer, time outside the ship appears to speed up. And now comes a mind-blowing fact. On October 15, 1991, a cosmic ray particle, nicknamed the Oh My God particle, struck Earth. We still don't know exactly what this particle was, but its name, the Oh My God particle, comes from its staggering energy level, equivalent to the energy of a baseball traveling at 93.6 kilometers per hour. Just imagine that amount of energy in a single particle. This particle was traveling at nearly the speed of light. To be precise, more than 99.99999999999999951% of light speed. Scientists still don't fully understand what could have accelerated this particle. Recent observations using the Telescope Array project suggest that it came from a region about 20 degrees off the constellation Ursa Major. Here's the most astonishing part. For this particle, time slowed down. Think about it. Compared to a stationary observer, time slowed down by a factor of 300 billion. This means that while we, stationary observers, would need 2.5 million years to travel from the Andromeda Galaxy to Earth, this particle would perceive the journey as taking less than 5 minutes. In fact, for light itself, time completely stops. This principle is clear, but the difference between your time and the rest of the universe's time is only part of the story. If you keep flying and don't turn back, once you pass the 8.3 billion light-year threshold, you can never return. There's no physical wall at that point. But once you cross 8.3 billion light-years due to the expansion of space, your causal connection to the solar system is severed. No matter how fast you try to accelerate, you'll never be able to get back near it. Why? Because the region of space you are in is now receding from Earth faster than the speed of light. This does not violate any laws of physics, because we're talking about the expansion of space itself, not the speed of any object within it. The same principle applies to galaxies across the universe. If you travel far enough from Earth, you'll enter a region where everything is receding faster than light speed. Even if you try to accelerate and return to Earth, you'll still be moving away faster than you can approach. But don't despair just yet. This is only part of the story. Even more mind-bending realities await. I've touched on them in my previous videos. Due to dark energy and the expansion of the universe, our visual range isn't limited to 13.8 billion light-years, but actually extends up to 46 billion light-years in one direction, and that's just for now. As space continues to expand, this visible sphere will also grow, though only to a certain extent. According to calculations, scientists estimate that our future observational horizon will extend about 33% farther than it does today, reaching roughly 61 billion light-years away. While our observable universe can expand, observable doesn't mean reachable. Dark energy, a powerful yet poorly understood force, has effectively divided the universe into concentric zones. Within a radius of 15 billion light-years, there are about 66 billion galaxies. Theoretically, if you could travel at the speed of light, you could reach these galaxies. But you would never see them as they are today. They will forever remain as fading farewell snapshots frozen in time. Between 46 billion and 61 billion light-years lie galaxies that are currently invisible to us. But our descendants will one day see them, because their ancient light will eventually reach us. However, for galaxies located beyond 61 billion light-years, neither we nor anyone else will ever be able to see them or reach them, even in the most distant future. Take the galaxy GNZ11, for example, one of the farthest known galaxies to date. It is 13.4 billion years old, meaning its light was emitted just 400 million years after the Big Bang. It is currently 32 billion light-years away from us, and though we can still see it today, its light will gradually fade away and eventually disappear forever. This galaxy is moving away from us at a speed of 687,000 kilometers per second, more than twice the speed of light. In fact, over 96.7% of the galaxies we can observe today have already passed the point of no return. The light they emit from now on will never reach us. Over time, one by one, each galaxy will slowly fade into darkness and isolation. And the emptier the space becomes, the stronger dark energy grows. The universe may become nothing more than an empty expanse, filled with dark energy. It will undergo exponential expansion. Now is a good time to return to our imaginary spaceship. If you continue flying at near light speed, by the time the clock on board the ship ticks to year 200, 10 forward years will have passed in the rest of the universe. That's a 1 followed by 41 zeros. At this stage, due to the relentless expansion of space, it's very likely that no other particles will remain in the observable universe except for the spaceship itself. Your ship will be eternally traveling through a pitch-black cosmos. So, is this what it looks like to cross the edge of the universe? Well, you could say, the first attempt to reach the edge of the universe has failed. The universe will have ended long before you ever reach any theoretical boundary. But this is only the beginning. All these assumptions are based on the idea that the universe is flat. But what if it isn't? What if the universe exists in higher dimensions? In the next episode, we'll unlock new journeys to the other possible shapes and boundaries of the universe.